There's three main learning concepts in Unit 5, and this is the final learning concept. This learning concept is on graphing rational functions. So we've learned how to simplify rational equations. We threw an equal sign in there and set two rational expressions equal to one another, and we solved then rational equations, and now we're graphing them. I'm going to see if I can move this little bar here to help me out as well. Okay, here we go. Now I do want to review one thing first. It's the word function. You've all heard the word functions, but what does that look like? So let's go back to very basics here, and you can just watch this. You don't need to put this part into your notes. If I was going to graph two equations, and I said, are they both functions? And what you would do is you would recall prior knowledge about how do we test to see if an equation, the graph of an equation is a function. And we would make vertical lines, do the vertical line test, and you'd be able to say, yes, this is a function, and I know that because for every purple line that I drew, it crossed the equation at most one time. And the reason for that is every x had at most one y. But over here, we made a line, a vertical line, and we can see that this line had actually two places in which it crossed the graph of the equation. So this is not a function. So and not only are we graphing equations, but we're graphing functions. And that's going to be an important concept moving through this. Now there are 4 types. I don't care that you know the types, you just know you need to know how to work with them. This is the first type, and we often say that this is in graphing form. The first 2 examples we do today are going to be in graphing form. So what do we know about graphing form? Well, if we go on to the next slide, know that you don't have to memorize this information. You do not have to memorize this information. This is going to be provided for you in simpler terms in your homework, and I will even post the rules on your Teams page. But we can make predictions about what this is going to look like. So if I was going to graph this in Desmos, since you don't have a graphing calculator in your hand, what you're going to notice is a few things. You're going to notice that there is what is an invisible line. It's an invisible boundary line. It's called an asymptote. I'm going to write that word up here. It's kind of a silly sounding word. It's called an asymptote. And asymptotes can go vertical, they can go horizontal, and they can even go diagonal. And because we're in virtual learning and we have less time than normal, I cut out teaching you about slant asymptotes. But I know that next year, for those that are admitted into pre-calculus, next year you'll learn about it, so it won't be missing as you move through your high school career. So today we're only going to talk about vertical and horizontal asymptotes. We may slightly discuss slant, but I'm not going to actually teach you how to identify it. So here's the equation we have, and I want you to know that in the denominator we are always able to determine what the vertical asymptote is. And we can determine that by taking this quantity, setting it equal to 0 and solving. So I'd move 3 to the opposite side and I get x equals 3. This is the equation of the vertical asymptote. And in this graphing form, I can also determine the horizontal asymptote. Remember, horizontal means from left to right. That's y equals -2. Simple question maybe, is it always going to be y equals for a horizontal asymptote? Always. And is it always going to be x equals for a vertical asymptote? It sure will. So let's look and see, what does this look like. So when I graph it, I want you to know that it's going to look like this. It's going to look like this, but I want to show you how do you do that. And the reason for that is in Desmos, if you give me 1 second here, you will be expected for your test, you'll be expected for your homework today, for quizzes, to be able to plug these in and then analyze. So we have y equals, I'm going to start with the parenthesis, 1 divided by, and I'm substituting in the equation, we have 1 divided by x plus 3. I use an arrow to go behind and close out the bracket or the parentheses and then subtract 2. So this is what it looks like, and I'm going to use this touch screen here to move it so we can see it a little bit better. And you're like, well, that's not making much sense, okay? Asymptotes are invisible. So when we put them on a graph, they help us to be able to analyze a graph. They're not visible on a graphing calculator. They're not visible in Desmos, and the reason for that, And the reason for that is because they're not technically part of the graph. So as I said, we had a vertical asymptote at x equals -3. And we had a horizontal asymptote at y equals -2. Now, see this little, it looks like a little gear here. If you go up to that, you're able to come over here and you're able to change the colors. And you could even change it from a solid line into a dotted line, okay? I'm going to do that right here. And now I'm able to easily see, oh, I see it, okay? The red is the actual function. The red is the function. The green in this particular graph goes from left to right. So from left to right is horizontal, okay? Left to right is horizontal. It cuts through the y-axis at -2. That's why we have y equals -2. And the orange cuts through the x-axis at -3, and that's why we have it labeled as the equation y equals -3. Now, what does the orange and the green line do? Well, they just provide structure to our graph. Asymptotes provide structure. Asymptotes, the actual function is going to approach those. If you want to think of them as walls, think of them as walls. It's going to approach that wall, but it never actually divides the wall. It never goes through the wall. It just gets closer and closer and closer. Okay, again, part of this standard is no longer going to be to graph by hand since we're in virtual learning, but you will be plugging it into Desmos and then analyzing it like we're going to do now. Okay, here's what we have, and we're going to go through 4 types. We're going to come back to this type last, and I'm going to explain why. It's just going to be a little bit more of like 7th and 8th grade math, but a little more detailed. So first, let's do the domain and the range. Okay, domain. It comes from the very far left, so -infinity, and this continues, until it approaches. Meets means that, it's actually touching. Until it approaches this vertical asymptote, which is the number -3. Now, it never touches that, and for that reason, I put a parenthesis. And then it's like it hops up and over, and it starts again, and it goes from -3 to positive infinity. Now, here's a new symbol that you may have known, and this symbol here is and. So this is a symbol. I want to make sure I put this symbol in correctly. That's one of the things I always seem to, the and or orange symbol, since I don't use them very often, I often find myself making a little mistake there. So give me 1 second to make sure before I move forward that I use the correct symbol, and I did, okay? So here's what we have. We have this portion and this portion. It's a union symbol. Now let's go through and do the range. Comes from the very bottom, so -infinity, and it keeps going up, oh, here it goes. It starts approaching a value of -2. Never touches it. And then it hops up and over and starts again and goes from -2 upwards. And we're going to use this and symbol. You're like, well, Miss, why do I have to write that symbol if I understand it? It's just the 2 different integrals. Well, it's possible that you will have a test that's not created by me, that's multiple choice. And it's possible that you see that symbol, or maybe they even throw a symbol that's upside down to try to mess up your thought process. And I want you to recognize what this means. Can you do me a favor, please, and stay actively involved here? Be honest, can I have a 1 through 5 on your level of 2 things? Your level of understanding how I just simply plugged this into Desmos and how I analyzed and achieved the domain and range. Can I please have a 1 through 5 to help me out? Never be afraid to put a 1 or 2 if that's where you feel like you're at. Okay, here we go. What are the asymptotes? Okay. Well, what a big mistake students often make is they go, okay, we have a horizontal at -2, a vertical at -3, done. This will get you no credit. It has to be in the form of an equation. So horizontal, hopefully you know that horizontal means from left to right. And if not, you're just learning that term. Horizontal means from left to right. It cuts through the y-axis at -2. So I go to horizontal, y equals -2. Now it's correct. Vertical. If you've been in sports, specific sports will check your vertical. See how high you can jump. So vertical is up and down. It cuts through the x-axis at -3. X-axis at -3. End behavior, if you recall, I once said to you, it'd be really nice if you had a stamp and you could just stamp it like this. All right, up to this point in your math career, you've learned that if you look and analyze the very, very ends of a function, the very ends, one of three things is happening. It's headed up, it's headed down, or it's staying consistent at one number. When you move into pre-calculus and we start to work with that slant asymptote, today you're just going to see it, you're going to be exposed to it, you're going to learn that sometimes these functions will follow a line. But at this point and this year, know that either the function is going up, the function is going down, or it's staying steady at a number. Now, this particular function, as it goes to the far left, it's getting closer and closer and closer, even though it looks like it's touching and never does. It's approaching the value, the y value, -2. And even over here, as I go to the far, 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 far right, it's approaching the value -2. Thank you for your continued feedback. I am keeping track of who's responding. Never be worried about what number you give me. Just be honest. So now we've done two things. We've identified the horizontal and vertical asymptote, and we've identified the end behavior. I want to review, since it's brand new to you, how could you do this if you didn't have Desmos? If you set the denominator equal to 0 and you solve, you'll always come up with the vertical asymptote. This is graphing form. We're going to see 4 different forms today. In graphing form, the number that's by itself will always be the horizontal asymptote. So it will always be y equals some number in this form. Can you give me a 1 through 5 right now on your understanding of how do I correctly identify the vertical and the horizontal asymptote and the end behavior? 1 through 5. Thank you again for your participation. Okay, we're going on to a new number now. Excuse me, we're going on to a new function. This should have said example 2. My apologies, this should say example 2. Now example 1 looked like this. It was f of x equals 1 over x plus 3 minus 2. So what have we changed? We've said, hey, let's change this 1 into a 10, and let's change it from positive to negative. I want to show you how the most basic of this function, if you take all this extra, I'm going to call this extra, if you take all this extra away, it would just be 1 over x. It's like the raw, it's the most basic function of this type. And this is called the parent function. And you're like, I just don't really understand the parent function. I get that, right? You're maybe hearing me use that term, but it's maybe new at 3-4. So the most basic parent function is y equals x for linear, or for quadratic, it's y equals x squared. It's the basics. We haven't moved it. We haven't translated it. In rational functions, in this form, this is the most basic. And I want to show you in Desmos, and this is really cool to understand, how from this, how do we get to here, and then what happens when we get here. We can make some cool predictions. So I'm going to right now clear out of the screen. And I'm going to clear this off. Oh. And let me copy and paste this so it's easy to get back in. Oh. There you go. There's the basic, okay? There is our basic. We're going to leave that as red. That's the parent function. It's the most basic. Nothing's been changed about it. Now watch that as I now slightly change it. And now all I've done is I've added a positive 3. From the red to the purple, if you had to describe that in words instead of in math, you would say you translated or you moved it to the left 3. Notice again that we do the opposite of what we see on the bottom. Okay, we move it to the left 3. And then what we do is we throw a -2 in back, and what we've done is not only have we moved it to the left 3, is we've translated or we've shifted it down 2. Okay? I'm going to take this one out, and I'm going to put in place those asymptotes that make it just a little bit easier to see. So it was x equals -3, and it was y equals -2. And I'm going to change those to colors that are kind of a little bit brighter and stand out for us. And remember, asymptotes, because they're not technically part of the graph, They are always going to be dotted lines when you graph them. And again, you may be saying, but yes, you told me I didn't have to graph. Right, you're not going to have to graph, but as you move up into your math, you will. Let's see if this is making, there we go. Okay, so this is what we have. And now what am I doing is that we're going to take this and look at what does this look like when I change it from here and I change it. So let's make a prediction. So it goes from purple, and when I put a 10 on top, look what happens. It's gone from what we see in purple to what we see in red. It's further away from those asymptote lines. Like watch it. Let's just make this up and say, what if I put a 20? If I put a 20, it's even further away. If I put a 30, it's even further away. If I put a 5, it's closer. Oops, excuse me. If I put a 5, it's much closer. If I put a 4, it gets closer. And a 3 and a 2, it gets closer. So, and what if I go below 1, like 0.5? Oh, it goes inside 0.4, 0.3, 0.2, and 0.1. What is the lesson I'm trying to show you? The number on top in this form, it's called graphing form, in this form, the number on top, if it's anything other than 1, in this case we see 10, if it's anything other than 1, it's either going to be a stretch, or it's going to be a compression. Anything greater than 1 is a stretch, and again we can see that there's 10, 15, 20. What do these stretches, 30. What do these stretches look like? Well, they're further and further away from the asymptotes. And if it's between 0 and 1, like 0.5, it's going to be a compression, which means it's going to be like sucked in closer and closer to the asymptotes. Thumbs up or thumbs down if you understand the relationship between that top number and what it's going to look like on the graph. We got one aspect here that I haven't added in yet. And I will tell you that only one student with 17 got this right last hour. Okay? So the one thing that's missing in this red equation that was included when we go back to the PowerPoint is there was a negative sign in front. So watch this really quickly. I'm going to do it, honestly, it sounds silly. I'm going to do it 5 times, and I want you to watch the movement here. Let's see if I can get rid of that. And let's see if I can move this in a little bit. Okay, so does everybody see the graph right now? Purple is what we have before I put this negative sign in, and I want you to just watch what happens when I go back and forth. What happens when I go back and forth? Only one student got it, so I want you to watch the distance and look what's happening. What is happening here? Does everybody see how it's reflecting? Does everybody see how it's reflecting? Let's see if I can make this even smaller here. So watch the red once again, and we want to say what is happening, where is it reflecting across is going to be the question. So there's the negative sign. Watch with red. If I go here to here, here to here, where is it reflecting across of? That's my question. Where is it reflecting across from? Anybody have an idea? Where is it reflecting across from? Go into the chat and give me your response. Is there a wrong response? Into the chat. We are really accustomed to say x-axis because x-axis is always the correct answer, except that this has been translated. So if I could say that if what we see in orange, if what we saw in orange was somehow the x and y axis, anybody that said right, yeah, anybody if the orange that we see was the x and y axis, then all of you that said x axis or y axis would be right, because it like just hops over the orange. But unfortunately, the orange is not the x and y axis because it's been translated. So instead, I think you have 2 answers. I think one answer could be the line x equals 3 because that's what I see. Watch really quick. Say, see this line? I'm going to count. 1, 2, 3, 4, 5. So it's 5 away. Now let's see if it's 5 away this way when it comes back. Watch. Okay, it's right here. 1, 2, 3, 4, 5. Does everybody see that? So the line x equals -3, it reflects across. Let's see if the same can be said about the line y equals 2. Does everybody see how this is exactly 2 away? Does everybody see how this point is exactly 2 away? Well, if it reflects across this line, then it should be right here where my cursor is when I put the negative sign in. And is it exactly at that point? It is exactly at the point. So whether you say y equals -2 or x equals -3, they would both be correct. They would both be correct. And for those that are like, well, isn't it the x-axis? Again, what we see in orange, whether it's going vertical or horizontal, it looks like the x and y-axis. It just represents the asymptotes after we've translated things. I'm going to come back now to letting us analyze this. This is example number 2, so don't be caught off guard by that. Remember, so let's look at, because heaven's sakes, there's so many terms on here, and this is a lot of information. Let's look at what really this is saying. This says, if I highlight, this says, hey, the zeros are the x-intercepts. We don't know. We don't care about that. Set the denominator equal to 0 and solve. That's going to give us the vertical asymptote. That's one thing right now. That's the one thing to take away from this part. So we already know that, and we can already see that when I set this equal to 0, I come up with x equals -3. And this part in back is the y equals -2. And we can see the negative sign doesn't have it over here anymore. It's now in purple. And this 10 makes it further from these asymptotes. Okay? Let's analyze this together. So, do we see some asymptotes, or sorry, do we see some x and y intercepts? And I do want to go back to the first problem. I realize I missed explaining x and y to you. Well, this is an exact point. I can see that. So the -8, 0 happens to be the x-intercept. Now the y-intercept doesn't look exact. So I'm going to review something with you, and let's stop and just take a break from this problem, and let's talk about mixed numbers. If I gave you the mixed number 1, 2 and 1/4, and I said, hey, what's that as an improper fraction? How would you do that? You take 4 times 2 to get 8, you add the top. So it's multiply going this way, adding going this way. So 4 times 2 is 8, plus 1 is 9, and then it's always over this magical number. 9/4 is the same as 2 and 1/4. What if that number was negative? You just forget about the negative to the end. 4 times 2 is 8, plus 1 is 9, so it's 9/4, and bring down the negative sign. You may be like, why are you going over this with us? Because I'm going to go backwards for a second here, so hold with me. Hold tight here. This was the first time that we were going to analyze it. I said, hey, we're going to come back to this. That's what I told you. So let me tell you that when we looked at, just to save ourselves some time, when I looked at it in the previous hour and I looked at this was a terminating decimal. It was exactly -2.5 and 0. There's no need to turn that into a fraction unless you want to. Terminating decimals means it's exact. There's no type of rounding. And then when I looked at this number, it was -2.667. That's what it showed in Desmos, but I want to give an exact answer. So I know that 0.666, and this is rounded, 0.66666 is the same as 2/3. 0.666 is the same as 2/3. So this is really -2 and 2/3. So how do I write that? -2 and 2/3 as an improper. So forget about the negative sign to the end. 2 times 3 is 6. 6 plus 2 is 8. So 8/3. Now throw that negative back in. 0 and -8/3 is the y. Let's practice that again with this problem. So again, I'm easily able to see that this is -8, and this doesn't seem exact. So I go into Desmos, and I literally hover right over top of it, and I see it's -5.33333. Okay, -5.3 repeating. So -5 and 0.333 is 1/3. So I want to change it back into an improper fraction. Forget about the negative. 3 times 5 is 15, plus 1 is 16. 16/3, there's a negative, and for the y-intercept, it's first 0, and then that quantity. That gives me an exact, precise answer without any rounding. Now, I don't think I did a great job with 0 in explaining that. Can I have right now a thumbs up or a thumbs down if you understand how I'm able to look at that number, if it's not exact, like -2.5 or -8, how I'm able to look at it, turn it into an improper, and then write it. Can you give me a thumbs up, thumbs down? just for almost feedback for me if I need to go a little more in detail with you guys. Wait for a few more before I go on. Thank you. Domain and range. Students generally do pretty well with this. So domain, it comes from the far left, and it continues to go until it approaches. That's a really important math word we use. It approaches. That means we never intersect. We never cross through it. Approaches -3, and then it like hops up and over, but doesn't go through it, doesn't touch it, and we go from -3 to positive infinity. And we're going to use this symbol to represent and. Range comes from the bottom, and it keeps going up until it approaches this number of -2, this imaginary, it's an asymptote, and then it hops up and over, never touching it, and goes from -2 to positive infinity. My experience in the past, most students get that have been in my class all year. Again, where do I see the biggest mistakes? And it really hurts me as a teacher when I'm grading a quiz or assessment and I can see you understand it, but at this point in the math career, it's important to be precise. So when they say horizontal, okay, this is horizontal, and you tell me -2, and this is vertical, and you tell me -3, can't give you the credit. Horizontal, where does it cross through it? Horizontal always crosses through the Y, and vertical always crosses through the X. And behavior. Just like the last problem, just happens to be coincidence here. As I go to the far left and the far right, the same thing is happening. Eventually, it's going to approach, gets closer and closer to the Y value of -2. So we've just gone over 2 problems that look like this. So we're going to move forward. Just know that's one of the 4 types. So maybe in your notes, you want to somehow identify that this is one type. This is one type of problem. We're going to see 4 different types today. And a definite struggle with students in the past is when they get to practice this on their own for homework, they get to a problem, they're like, well, which type is it? And they want to ask me to identify it for them. And then they feel like, oh, once they know which type, they know what to do. This is one type, okay? It's in this form. There's some number all the way in the back. There's no variables on the top. There's only variables on the bottom, okay? So now let's move on to the next type. Now, I'm going to identify this type as the degree on the top is the same as the degree on the bottom. You maybe want to write that down. For examples 3 and examples 4, degree in numerator is equal to the degree, it's not neat to write on my screen, it's the degree in the denominator. And if you're thinking that doesn't matter, that totally drives how we do this problem. If you're hopefully familiar with the terms numerator and denominator, numerator's on top, denominator's on the bottom, what is the degree? Degree would be the largest exponent on the variable, and I can see they're equal. It doesn't matter what number they are. They can be 3s, 1s, 2s, 5s, but if those 2 numbers, the highest on top is the same as the highest on the bottom, then what we need to do is we need to follow this rule. If the degrees are the same, if the degrees are the same on the top and the bottom, if the degrees are the same, then it tells us exactly what we have to do to find the horizontal asymptote, okay? That's where you'd refer to this step. All right, now we're going to do this together. Easier than you think, by the way. There are 3 things we can take from this. And I'm going to abbreviate because I'm kind of lazy. We can figure out the vertical asymptote, the horizontal asymptote, and we can see if there's any x-intercepts. Remember, another words for x-intercepts would be roots, solutions, zeros. Roots, solutions, zeros. They're all interchangeable with x-intercepts. So what can I figure out here? Well, I'm going to take this equation, I'm going to rewrite it. And I'm just going to put a y here to make it easier. I have 2x squared, and I can see that this factors into x plus 2 and x minus 2. The denominator for every problem you do in any one of the forms, you take the denominator and you set it equal to 0. We happen to have 2 different factors here, so I set it equal to 0. And then I solve. So x equals -2 is one answer, and x equals positive 2 is the other answer. I just figured out the vertical asymptotes. The vertical asymptotes was x equals 2 and x equals -2. Vertical asymptotes always come from the denominator. All right, so in this form, When the degree is the same on top as it is on the bottom, we can figure out the horizontal asymptote by taking the numbers in front of those degrees. So 2, and then you're on the bottom, you're like, but there's nothing. Do I put a 0? No, there's a hidden 1. So horizontal asymptote is 2 over 1, which is equal to 2. Y equals 2. There's horizontal, there's vertical. In this form, there's one last thing we can always determine, and that is the x-intercepts. You take the top, you set it equal to 0 and solve. First I divide by 2 in this case, and then I ask myself, okay, I can have a 0 on top, that's okay. What's the only number I can square? And then when I square that number, I get 0. And the only number you can do that with is 0. There's x-intercept, horizontal, and vertical. So when you graph it, it looks like this. And I'm not going to take time to plug it in just to save you some time. It looks like this. And remember, we already identified, I'm going to do this in a bright color. We identified here, maybe I should do the same color, y equals 2, y equals negative 2. Thank you for your patience here. I said y, I was writing down x. X is correct, my apologies. Y equals 2, and we can see this is the x-intercept. Again, vertical was at 2 and negative 2, x equals 2 and negative 2. I unintentionally said y when I was writing it. And then we have a horizontal asymptote at 2, we can see that, and we have the x-intercept. We're ready to go. All right, so what is the x-intercept? Well, it just happens to be that the only x-intercept is the only y-intercept, and both of them have to be 0, 0. What is the domain? Okay, this is a little tricky. It comes from the far left, and it continues to come until it approaches this line, this hidden line, this asymptote. It never touches it, just approaches it. What do we call that line? We call that line negative 2, and then it jumps over it, and then it starts again. Oh, goodness sakes. What just happened? There we go. And then it goes again. Sorry, I'm having some trouble here. Then it goes again from negative 2 to positive 2, and then it jumps over and it goes again from positive 2 to infinity. And in between each of these, we're going to put the little end symbol. Oops, excuse me, good news, go the other way. There we go. Remember I told you before I needed to be careful. I seem to make small mistakes there. A union symbol. Okay, you ready? So about 50% of students got the next one right, 50% got it wrong in the previous hour. I want you to type in what you think the range is for this problem. Use the U symbol to represent the union. Please go ahead, let's see who's participating. I'm looking for you to put into the chat and tell me identify what is the range. All right, so there must be some overlying confusion here with the range because nobody's provided me an answer. So for the range, it comes up from negative infinity. Comes from negative infinity. Thank you, Steve. Comes from negative infinity, and it keeps coming up until it hits 0. And then it starts again at 2, and it goes to positive infinity. Steve, I'll tell you, that is extremely, extremely close. Oh, Steve, you got it. I didn't look close enough. Awesome, Steve. Great, great job. Okay, so it comes up from negative infinity to 0, but here's the deal. This point is not an asymptote. It's a point actually on the function. It's a point on the function. Somebody appears to be getting back into class. I'm getting individual messages, so give me 1 second here. My apologies, but I know it's hard when some of our internets are inconsistent. Thank you, Steve. Amazing. So here's what it does. It comes up again from negative infinity. It goes as high as x equals 0, and it's actually a point there. That's why Steve included it in his answer he provided us. Great job. And then there's nothing here. In the whole graph, there's nothing here. And then it starts again after it leaves 2. We don't include 2 because although it's approaching, it never touches, and there's no limit how high it goes. That is the answer for range. That is a commonly missed question that you guys can do. Asymptotes. Okay, again, horizontal is y equals 2, vertical is x equals 2, and x equals negative 2. And end behavior, I'm not going to write it out, but in both sides it is approaching positive 2 as it goes to the far left and to the far right. Okay, so we just did what is in blue, and now example 4 is what's in red. Example 4 is just like example number 3 in the fact that the degree in top is a 1, the degree in the bottom is a 1. Thus, the degree in the numerator is the same as the degree in the denominator. Okay? You have to be able to recognize. I just want to show you really quick. Here was example 1. Example 1 looked like this. That's example 1. Okay? And then here's example 2. Looked like this. Example 1, example 2. Those were graphing forms. That's one type. The second type you're learning about is when the degrees are the same. It doesn't matter what that number is, but they're the same. And there's 3 things you can come up with. Okay, are you ready? Here we go. This is a race here. I need you guys to go as quick as you can. Are you ready? Here we go. I need you to type into the chat for me. Give me the equation of the vertical asymptote. Go. I need everybody to participate. What is the equation of the vertical asymptote? So you're going to say x equals a number or y equals a number. Begin. Thank you, Rodrigo. You're taking this number and you're setting it equal to 0 and you're solving. When you set it equal to 0 and you solve, you get, thank you, Jocelyn. Thank you, Anaya. Thanks, guys. You get x equals negative 1. I'm lazy, so my apologies, but I'm just going to write VA. That is the vertical asymptote. Okay, you ready? This is a tricky one. Thank you to all those who participated. Okay, here's your next one. Tricky. You ready? What is the horizontal asymptote? Horizontal asymptote. That's a tricky one. Nice job, Benny. But, oh, you're so close, Benny. No. Re-examine. Nobody's giving. Nice job, Mia. Oh, close. Close, Destiny. We're on this problem over here right now. We're in the red. Good job, Sam. Okay, so here's what we have. This is why it's so tricky. When you're figuring out when they have the same degree, we can look at the equation and we look at the numbers in front. Now, why is it tricky? Santiago asked me an awesome question earlier this week. He said, when you have this negative at the same level as the division, like what does it belong with? Does it belong with the numerator on top or the denominator on the bottom? Is it with both? We just kick it up to the top. So I have a negative 1 on top and I have a positive 1 on the bottom. And you can identify the horizontal asymptote by taking the top divided by the bottom of those numbers in front of the degrees. They're called leading coefficients. So the horizontal asymptote is always y equals, and it's negative 1 over 1. So y equals negative 1 is the horizontal asymptote. So we've done horizontal and vertical. And now how would we figure out the x-intercepts? Remember, I kicked this up to the top, so it looks like that. You take whatever you have on top and you set it equal to 0 and you solve. But here's the deal. This was out front like this. Watch this really quick. It was really like this, and I think it's times that whole thing. So if I look back to this, if I look back here, this is why I believe it is. When I look back here, we get an answer of positive 3. So this negative sign needs to be multiplied by everything here. So I'm going to put a negative 1 in front, but it really needs to be multiplied by everything here, and then I set it equal to 0. So okay, so I multiply it, so I have negative 1x, multiply it positive 3, and if you're one of the students that are like, what is she doing? When you take the numerator and you set it equal to 0, you'll find the x-intercept. Subtract 3, negative 1x equals negative 3, and then when I divide by negative 1, I get an answer of 3. So x equals, x equals 3, or 3, 0 would be the x-intercept. If you're wondering again, where does this apply here? So if the degrees on the top are the same again, we are going to divide the leading coefficients. That's how we figure out the horizontal asymptote. Okay, so we've done that, and we can see here's the x. Okay, got it. Oh, this is an easy y. It's exact. It is 0, 3. We just happen to be lucky there, so that's an easy one. And I don't know why I didn't show it here, but the horizontal asymptote is negative 1. That was just a mix-up on my part. And are the horizontal and the vertical asymptotes always going to be the same numbers? Like in this case, it's negative 1 for both? Nope, not true. That just happens to be a coincidence. So let's go through and analyze. We can see that we have 3, 0 and 0, 3, also just a coincidence that they happen to be flipped. And the domain comes from the far left, and it approaches negative 1, and then goes from negative 1 to infinity. Comes from the bottom, negative infinity, approaches negative 1, and then negative 1. Okay, asymptotes, again, negative 1 for both will be wrong. Well, what if you put, another question is, what if I put x equals here and y equals here? And Ms. Bradley, you know what I mean. No, at this point you need to be precise. Horizontal is always y, and vertical is always x. And the end behavior for both, we can see as I go to the far left and the far right, is again both approaching negative 1. Okay, you ready? I want you to come up with a 1 through 5 rating on right now after end behavior is new to this class. We learned it in the first quarter, and we just keep applying it to functions. I want a 1 through 5 on your level of comfort. When I provide you with a graph and I say, what's end behavior? I want a 1 through 5 on how comfortable are you with assessing end behavior of any graph when I provide you with the graph. 1 through 5. How comfortable are you with assessing end behavior? How do we read this again? So this tells me I need to go a little more in detail. My apologies. I thought these would be higher, and that's okay. As I go to the far left, what's happening? It is, oh, so sorry. As I go to the far left, it is approaching but not touching negative 1. As I go to the far right, it is approaching but not touching negative 1. Some students may be like, well, isn't it going up? Well, no, it's not going to keep going up and over. It's not going to intersect this horizontal asymptote. It's gonna have like a limit on how high it can go, and it will never actually go all the way up or all the way down to negative 1. All right. So now we have. Notice that the previous one, these are the same. Does everybody see that? These are the same. Now we have something different. What is different about this? This is the third type. Example number 5 is the third type, and this time the degree on top is larger than the degree in the bottom. So we have done graphing form, we have done when the degrees are the same, and now we're going to do where the degree on top in the numerator is larger than the degree in the bottom. Make sure to write that down. You'll want to be able to refer back when you do your homework. Okay, so there's a couple things to write down about this. Here's the first thing. Before I get started, I'm like, hey, I recognize something. Not only do I recognize the degree on top is larger, I also recognize that this is the same as x plus 3, x minus 3, all over x plus 2. And I can't, like we've learned in the first 2 days of this unit, how to simplify rational expressions. I can't simplify anything there. But maybe I could, so it's always important if you can factor to first check. Okay, I can't simplify anything. So here's what I need you to write down. There is no horizontal asymptotes. There's no horizontal asymptotes when the degree on top is larger than the degree on the bottom. There's never any horizontal asymptotes. Never, never, never. When the degree on top is larger than the degree on the bottom. Will there exist a vertical asymptote? Yep. And we are able to identify it in the same way. Take the bottom. You can even do this mentally. Solving, we get x equals -2. This is the equation of the vertical asymptote. Can I still figure out what the x-intercepts are from the top if there's a variable? Yes. So in this case, I get to set each one of these equal to 0. X plus 3 equals 0. And x minus 3 equals 0. And that tells me what the x-intercepts will be. So I've identified the x-intercepts. I've identified that there's no horizontal asymptote. And I've identified the vertical asymptote. And the graph looks like this. So that's, by the way, when you're looking at this, that's what this says. This says if the degree in the numerator is greater than the degree in the denominator, we have something called a slant asymptote. And I'm going to expose you to that today. But again, that's one of the concepts I'm taking out since we're in block, and we can't get through all the concepts with limited time, and you not being able to be in class and ask questions. So here's the picture we have. I can see that I have a vertical asymptote, which I've already identified as x equals -2. I'm able to see the 2x intercepts. I'm going to figure out what that y-intercept is in just a little bit, and there's no horizontal. Now, you may be saying, like, what's this whole slant thing? Well, if you are unfamiliar with the word slant just means an increase or a decrease. It can be going this way or going this way. It can be a rise or declining at different rates. And if I provided you this exact graph at home, and I said, all right, let's see if I can do this, by the way. And I said, take this graph, and I want you to fold exactly on the red line. The red line is directly in between the two purple parts of the graph. And if you folded them, you'd find that this graph is going to lay directly on top of this graph. This is it's a way to split it or to make it symmetrical on the left and on the right. Okay? But it's at a slant, so they call this slant asymptote. And when you move to pre-calculus, if you were given permission to move on to pre-calculus, they're going to teach you this concept in pre-calculus. And it's not hard. If we even had an extra day in the curriculum, we do polynomial long division. You've already learned that. It's not hard, but you're going to be taught it next year, and it's one of the concepts that I'm able to cut out. So, I'm going to go back, and I just want to, since we have so much information in this, I want to really cut to what do we know. We know, once again, we can look at the bottom. When the degree on top is larger than the degree on the bottom, we can say there are no horizontal asymptotes ever. Nope. But we can say the vertical asymptote is x equals -2, not just -2. And I'm able to factor and solve to see what the x-intercepts are. So I've identified the x-intercepts as 3 and -3. We're going to go back and do the y-intercepts in just a second. And we do that by, thank you for your patience here, -2 and positive. Okay, here's the graph, and see how I go to the topic and I'm like, oh, yep, there's an x-intercept, just like I algebraically found. I come down here, oh, it's a terminating decimal. You may be familiar with those terms and really not know what that means. Terminate means to stop. If your job terminates, it stops you. They're going to let you go. It terminates. This is a decimal that terminates, which means you're not rounding. It just stops after 0.5. And when you have an answer that just stops like that, it's not rounded. So I can provide that as an answer. I don't need to turn it into some type of an exact fraction in order to be precise. There we go. We've already identified the x-intercepts. Domain. Okay, so here we go. This is a little bit tricky. It goes from the far left. It goes from the far left. Okay, but it never actually touches. It approaches but never touches -2. Please go into, no, that's too hard to do since you don't have that symbol. What's the range? There's no limit how low it goes. Watch, there's no break. There's no break. There's no limit how high it goes. There's no limit how high it goes. So this goes from -infinity to positive infinity. There are no existing horizontal asymptotes. The vertical asymptote is at x equals -2. Yes, there's a slant asymptote, but no, I will not make you identify the exact equation of it. And behavior, I definitely want to go over that since the feedback you provided me today in the chat was that although you felt some confidence, it was kind of an average level. It wasn't very high. What does this mean? So as I go to the very, 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 very far left, what's happening? So what's the general consensus here? Is it going up? Is it going down? What's happening? So I can see that it is tending to go down. Do you see that? It's tending to go down. We're going to go to negative infinity. And over here, what's happening? It's tending to continue to go up to positive. Oh, this looks much like example 5. Why is that? The degree on top is larger than the degree on the bottom. Remember, that's right here. Numerator degree is greater than denominator degree. Okay? So let's start by factoring. This would be x plus 3. And, okay, I want to make this a little bit neater for you guys because this is going to just change a little bit. X plus 3 and x minus 1. X plus 3 and x minus 1. And then down here is x plus 3. Here's what I have on top and here's what I have on bottom. Now, how is this different than the last function? Well, the last function, when I factored, I was like, I can't cancel anything out. But here, look at, I can cancel out. And all I'm left with is an x minus 1 on top. So when I get to graph it, it's like really like graphing a line x equals 1. Oh, well, how do you do that? If you've forgotten how to do that from freshman year, you start at -1. The slope is 1 over 1, so it's up 1 over 1, up 1 over 1, up 1 over 1. And the graph looks like this. Here is the difference. When you graph this, remember you can never ever have a 0 in the bottom. And what's the only value that you would plug in? Well, remember, we can still figure out the vertical asymptote. That means take the bottom, set it equal to 0, and solve. So x equals -3. X equals -3 is the vertical asymptote. And that's why there's a hole here. Because it says, hey, you can approach that, but you're never actually going to actually cut through it or intersect it. That's the reason for that. We can see that the x-intercept is 1, 0 from this graph. The y-intercept is -1, 0. Again, you may be like, why is there a hole in the graph? I don't get it. Because when you find the vertical asymptote, remember, an asymptote, you can approach it, but you never actually go through it. If we substituted -1 in here, would be a -3 in here would be trouble. We'd get 0 on the bottom. It breaks the math rule. Never can have 0 on the bottom. So domain, here we go. It goes from -infinity all the way to an x value. Intervals describe x values all the way to an x value of -3, but it doesn't touch it. Okay, hops over, and then from -3 to positive infinity. The range. So at this point, there's an x value of -3 and a y value of -4. Comes up from -infinity, and it keeps coming up until it gets to a y value of -4. Again, it jumps over that little circle there and goes from -4 upwards. Can I have a thumbs up or a thumb down based on your understanding before I do end behavior? Based on your understanding, can I have a thumbs up or thumbs down if you're understanding how we have a hole in the graph and the reason for it? Thumbs up or thumbs down, please. I know I'm never going to get 100% of you, so just know that when it comes to the time to the homework and I'm conferencing with you, you can definitely ask me individual questions. Also, tutoring will resume. It will be over graphing. Tutoring will resume on Monday from 8 o'clock until 8:30. What is the horizontal asymptote? There is none. Don't put 0. I don't want to be confused. There is none. NA. Or write the word none. Vertical asymptote is x equals -3. Yes, there. Okay, we got that done. And behavior. As I go to the far left, what's happening? It's going down. As I go to the far right, what's happening? It's going up. So we've done 3 types of problems. We've done, I want to do them right here. We've done a problem. I'm going to just do one of the 2. We've done something that looks like this. Okay, we call that graphing form, all right? You may have to go watch them back and watch the video. We've done something like, let's look at this. All right, we could say the degree on top is the same as the degree on the bottom. Then we went ahead and we did things like this. I'm just making a problem up here because I'm forgetting. Where, let's say it was like, where the degree on top, the exponent on top of the variable is greater than the exponent on the bottom. And now our last type, our very last type that we're going to analyze is what happens when the degree is larger on the bottom. And you may be able to say, like, well, how can I analyze? Well, if you don't see an x on top, it's x to the 0. So we can see that the degree on the top is 0 and the degree on the bottom is 2. What would be the rules? Oops, sorry. And here would be the rules. If the, my fault. If, oh my goodness. If the denominator's degree is greater, we have an x squared down there, then there will always exist a horizontal asymptote at y equals 0. That's what's always going to happen. So let's look at this problem and let's make a few predictions. When the degree on the bottom is greater, it said there will always be a horizontal asymptote, always, 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 at y equals 0. That will always exist for any problem. If the degree on the bottom is greater, we will have a horizontal asymptote of y equals 0. Now we can still, just like every problem we've done, we can figure out that the vertical asymptote, if I set this equal to 0 and I ask myself, what is the only number I can square? The only number I can take times itself and still get 0 is 0. This is the vertical asymptote. This is the horizontal asymptote. Now let's take a look and see what does this look like, okay? So give me a second here. It is our last and final problem. And I'm going to change this. Here's what we have, okay? It looks like this. And remember, we determined that the vertical asymptote was x equals 0. The horizontal asymptote, it says, will always be y equals 0. And I'm going to come back here and change those to maybe some bright colors. Okay, and now if I zoom in, let's make those green actually, because otherwise it's really easy to have the orange and the red kind of look the same. If I zoom in with my fingers, I can see that as they go up, they're getting closer and closer to that vertical line of x equals 0. And as they go to the far left and far right, although they're never going to cross it or intersect it, they're approaching the x-axis, which is the same as the line y equals 0. So, I would like you to share with me, what is the x-intercept? Please go into the chat. What is the x-intercept? Looking for your answers. What would be the x-intercept? Steve's right on this. Nice job, Steve. Nice job, Jocelyn. Okay, Louise, thank you for participating a lot today. I really appreciate it. So I'm going to use Louise. Louise has given me a lot of right answers, and I know this is like a hard one. If this was a test, I know exactly what Louise is trying to tell me. Saying none or as saying NA is acceptable. Louise said 0, and what I know, I believe I understood Louise to mean like there is no x-intercepts. But when you say 0, it could be interpreted that the x-intercept is 0. So this red function, this line represented in red, will never actually intersect. It will never touch the x-axis. So there are no x-intercepts. Likewise, there are no y-intercepts because it will never actually intersect. It will never intersect the y. So thank you for doing that for me, Louise. Thank you for your participation. We don't want to say 0, even though I probably would understand what you mean. To be precise, we want to say NA or none for x and y intercepts. Okay, you ready? I'm going to challenge you. I would like you to just do a really rough graph of what this looks like on your paper. I'm going to give you 30 seconds. I'm going to ask you some questions that are very similar to a question on your upcoming test or quiz. So, again, draw a quick picture of what this looks like. Ladies, I want you to write the interval in which this function is increasing. Where does it increase? Gentlemen, I want you to write an interval in which this function is decreasing. Where does it decrease? Where is it increasing, females? Where is it decreasing, gentlemen? So a couple reminders, when you write those intervals, they're always described in terms of x values. That's one. When you analyze a graph, it's always from left to right. So think of yourself as running, riding a bike, skateboard. From left to right, you're going up. So this is increasing. From left to right, you're going down. This is decreasing. So ladies, in terms of x values, this would be negative infinity. Now, where does it increase to? That's really tricky. Really tricky, okay? It continues to increase until you are approaching but never touch 0. So from negative infinity to 0 is where it increases. Gentlemen, it is decreasing from 0 to positive infinity. That doesn't mean it touches 0. It means after it leaves 0, on the other side of 0, as soon as you see the line, it is going down. It's constantly going down. Okay, make sure the order here you write these down in does matter. So if you'd put 0 first, it would be wrong. End behavior here in both these cases, just to talk about that, when you go to the far left, it's approaching 0. As you go to the far right, it's approaching 0. It doesn't mean it touches, it means it gets closer and closer to 0. Again, we've already stated that x equals 0 is the vertical, y equals 0 is the horizontal. Remember that when the degree in the bottom is greater, you will always have a horizontal of 0. Do you have to memorize this? Nope. You have to know what this means. Can you make your own notes that you can use for a quiz or test? Absolutely, but you have to be neat because things are timed. Now, before I let you have a break, give me 1 second.